day, learners. This video lesson will focus on the measures of position of quartiles, deciles, and percentiles of ungrouped data using Mendenhall and Sincich method. I'm Equationator Ashleya, and I'll be guiding you through this process. By the end of this video, you'll understand how this method provides a systematic approach to understanding the distribution of data points within a data set. The quartiles are the score points which divide a distribution into 4 equal parts. So as you can see on the screen, quartile 1 is 25%, quartile 3 is 75%, and quartile 2, which is in the middle, is 50%. The formula is k multiplied by the quantity of n plus 1 over 4. If we are looking for the first quartile, and the answer you get is not a whole number, then we have to round up. For example, 2.3 will be 3 and 2.7 will become 3. Meanwhile, if we compute for the third quartile and we do not get a whole number, then we have to round down. For example, 6.3 will become 6 and 6.7 will become 6. The same rule applies for deciles. If we compute for decile 1, decile 2, decile 3, and decile 4, and we do not get a whole number, then we have to round up. And if we solve for decile 6, decile 7, decile 8, and decile 9, and we do not get a whole number, then we have to round down. The formula for decile is k times the quantity of n plus 1 over 10. Percentiles are the values divided into 100 equal parts. The same rule as quartiles and deciles also applies for percentiles. If we solve for anything in between percentile 1 and percentile 49 and we do not get a whole number, then we have to round up. Therefore, if we solve for percentile 66 to percentile 100 and we do not get a whole number, then we have to round down. The formula for percentiles is k times the quantity of n plus 1 over 100. Now, here are a few examples. Find the lower and upper quartiles of the score of 13 students in their 20-item math quiz, given the dataset 4, 8, 12, 15, 2, 7, 20, 5, 9, 18, 16, 6, and 10. Now, the first step is always to arrange the numbers in ascending order. Now we have 2, 4, 5, 6, 7, 8, 9, 10, 12, 15, 16, 18, and 20, a total of 13 numbers. Now, let's solve for the lower quartile. So first we put in the formula, then we substitute the given. So instead of writing 1, I put in 0.25 times the quantity of n plus 1. Next, I changed n into 13 since it is the total number of students who took the quiz. Next, we add what's inside the parentheses. So 13 plus 1, we get 14. Then, we divide 0.25 and 14, we get 3.5. Since it is not a whole number and it belongs in the first quartile, then we have to round up. So 3.5 is now 4. Therefore, the lower quartile is the fourth data, which is the number 6. Moving on, let's solve for the upper quartile. So, first we put in the formula, then we substitute the given. So, instead of writing 3, I put in 0.75 times the quantity of n plus 1. Next, we change n into 13 since it is the total number of students who took the quiz. Then we add what's inside the parentheses. So now we get 14. Then we divide 14 divided by 0.75. Now we get 10.5 since it is not a whole number and it belongs in the third quartile. Then we have to round down. So 10.5 is just 10. So the upper quartile is the 10th data, which is 15. Example number 2. A group of students obtained the following score in statistics quiz: 4, 8, 9, 12, 7, 15, 14, 6, 10, and 11. Let us find decile 3 and decile 8. Step 1 should always be to arrange the numbers in ascending order. So now we have 4, 6, 7, 8, 9, 10, 11, 12, 14, and 15, a total of 10 numbers. To solve for decile 3 and decile 8, we have to know the formula. So the formula is k times the quantity of n plus 1 equals 10. Then we substitute the given. So k is now 3 since we are looking for decile 3, and n is now 10 because it is the total number of students. Then we add what's inside the parentheses, so now we have 11. So 3 times 11, we have 33, and copy 10 as is. Then, if we divide 33 and 10, we get 3.3. Since we got 3.3 and it's not a whole number, then we have to round up. So 3.3 is now 4. Therefore, decile 3 is in the fourth data, which is 8. The same goes for the solution of decile 8. We have to substitute the values given. So 8 times 10 plus 1 over 10. After adding what's inside the parentheses, we now have 8 times 11, which is 88, over 10. 88 divided by 10 is 8.8. Since it does not belong to the lower decile, and it's not a whole number, then we have to round down. So 8.8 is now 8. Therefore, decile 8 is in the 8th data, which is 12. Moving on to example number 3. The list shows the numbers of bottles of strawberry jam sold in a day by 14 different vendors. 20, 18, 16, 10, 12, 15, 13, 9, 11, 16, 15, 16, 18, and 20. Let's solve for percentile 15 and percentile 80. Next, we arrange the numbers in ascending order. Now we have 9, 10, 11, 12, 13, 15, 15, 16, 16, 16, 18, 18, 20, and 20, a total of 14 numbers. Now let's solve for percentile 15. First, we substitute the given. So instead of n, we put in 14. Then we add what's inside the parentheses. So 15 times 15 is equals to 225. Then we divide it to 100. Now we have 2.25. Since it belongs in the lower percentile, we have to round up. So 2.25 is now 3, or located in third data. So percentile 15 is 11. Therefore, 15% of the sale distribution fall below 11 bottles. Lastly, let's solve for percentile 80. After substituting the given, we now have 80 times 15 over 100. So 80 times 15 equals 1,200 over 100. Then if we divide the two numbers, we get 12, which is a whole number, which means we neither have to do round up or round down. Percentile 80 is the 12th number located in the data set, which is the number 18. So, therefore, 80% of the sale distribution fall below 18 bottles.